Okay, in this video I'm going to try to explain the concept of differentiation. Okay, suppose we have a function f of x, which is the dependent variable, and we have x as the independent variable. Now, a question that usually arises is, how fast does the function f of x change with respect to x? Okay, this is where differentiation comes in, and we refer to this as the derivative of f of x. And differentiation has many applications in economics, in sciences, in almost everything. In a more scientific term, differentiation is trying to calculate the rate of change, or the instantaneous rate of change. In economics terms, it's the sensitivity. And the way we denote the derivative of a function is by dy over dx, so the change in y with respect to x. And this is the way Leibniz uses notation. And we can also write the derivative of a function with f and then x. This is the way Lagrange represented the derivative of a function. The derivative of a function can also be explained in terms of limits. So suppose we have a function f of x. This is f of x, and we want to find the rate of change at this point x. So if we evaluate this point at x, we have f of x. Suppose we have another point around here. We can approximate this with a straight line. Now we can find the gradient from here to this approximation, and this approximation can be anything. So let this be delta x, a small change in x. So our new point will be x plus delta x. And if we evaluate this point x, we should have f of x plus delta x as the function. Okay, so now the way limits work is, if we take this point, this new approximation point, and reduce it, so make the width smaller and smaller, so as this tends to 0, then we would find the instantaneous rate of change at the point x. So here we have the difference. So remember, gradient is simply rise over run. So the rise is f of x plus delta x, subtract f of x, that's the rise, and the run is the width, and the width here, the chain, is just delta x. So as delta x goes to 0, then we would find the instantaneous rate of change, and that's how the derivative is defined.